Hi and welcome back to my channel. This week's video is about solving this problem here, and that is finding the area of the grey square. Now we've got three squares here. We've got a larger square on the outside, we've got a square at the bottom left of that square with an area of 9 centimeters squared, and then we've got the diagonal of the larger square, as you can see, touching the top right corner of the 9 centimeter square, but also we have this grey square which lies on that diagonal, and two of its vertices touch the outside also of the larger square. Now what I'm going to do is I'm going to show you the vertices labelled so that you can use that if you want to write down your solution in the comments, or if you find a different solution, again writing that down in the comments and sharing that. Or also maybe if you find a problem, an issue, sharing it down in the comments makes it a bit easier. Right, now I'm going to show you two different solutions to this problem. And they're both quite nice, quite neat, I think. See what you think. If you want to go through the problem yourself, pause the video now because I'm going to go through my solution in 3, 2, 1. Okay, now the first thing to notice is, well, we've got squares, so we can start filling some things in, and we've got a 9 centimeter square there. So we can put right angles in all over the place here. So we've got quite a few right angles and some that I haven't labelled just because we're going to split those up into two separate angles later on. And I'm not going to put the right angles inside the squares because they're squares. We're just going to assume, well, I'm going to assume that you know they're right angles inside the squares. Now the next thing is we know the side length of the 9 centimeter square. That's 3. 3 squared is 9. And we can then start looking at some angles. Now these angles must have to be 45 degrees, and you'll see why these other threes that I've labelled along the top and the bottom have to be threes in a second. So we've got 45 degrees, and those 45 degrees have to be 45 degrees because we've got the diagonal of the square. So that's going to split 90 degrees exactly into two 45s. Now what we also know, angles in a triangle add up to 180 degrees. So these other angles that I've now labelled must also be 45 because you do 180, take 90, take 45. Now that means we've got an isosceles triangle. And that is where we get these other threes on the outside of the square from. Okay, along the top left and the bottom right, because we've got isosceles triangles. They've got two angles that are the same, so we're going to have two sides that are the same. Okay, so they must also be threes. Now that gives us a side length of the larger square of 6, which will be important for later. Now the next thing we can do is start working out these angles. I say work out, it's fairly straightforward. Again, 90 take 45, and by the same principle as before, we get that these are 45. Okay, and in a very similar way, these are 45. Okay, now from there, what we're going to do is I'm going to start to label some of these sides. So I'm going to call this side at the top X and the same side on the bottom right of the larger square, because those triangles, they are going to be similar triangles because they have got a shared side and they've got the same angles. Okay, so they've both got a side which is an area of this A square, capital A square. Okay, and they've got all the same angles. So those sides are going to be X, and I'm going to call these sides Y. And again, they must be the same because isosceles triangle. Okay, now from there, what I want to do is, well, I've got two options because I've got right angle triangles. I can use trigonometry or I can use Pythagoras. Now, we need to label the sides of the square though first. It doesn't really matter what we call them, but I'm going to call them A because capital A is the area, so we'll call the sides lowercase a. But you can call them whatever you want. Now from there, I'm going to use Pythagoras. And using Pythagoras, what I get is A is equal to the square root of y squared plus y squared. And that is the triangle from the top right of our largest square. Okay, some of your two shorter sides, when you square them and then add them together in square root, is going to give us the hypotenuse. So in that case, A. Now we're going to do the same thing. Actually, we're going to simplify that first. Let's simplify that first, and then we'll do the same thing with the X and the A's. The top left triangle, if you like, and the bottom right triangle. So the two A's and the X. Pythagoras again. But we'll simplify this first. So we get 2y squared, because that's y squared add y squared, inside the square root symbol. Now, I want to get y equals because then I can do x add y, hopefully, and I can get that equal to 6 and then solve it from there. So I'm going to square both sides here, and that's going to give me a squared is equal to 2y squared. I then need to divide by 2, so I get half a squared is equal to y squared, and then I need to square root that. So I square root the 1 and I square root the 2. Square root 1 is 1, square root 2, can't square root that, so just leave that as root 2. Square root the a squared, and we get a. So we get 1 over root 2a. Now that's y. We're going to do the same thing with the x, but in this scenario, x is the hypotenuse. So we're going to do square root of a squared add a squared. That's the square root of 2a squared, and we can again simplify that by square rooting the 2 and square rooting the a. But remember, we want x as the subject here in the same way that we wanted y as the subject before. So we, like I said earlier, we can add those together and they will be equal to 6. So we get root 2a is equal to x. Now I'm going to replace those letters on our diagram. So we get root 2a as x, and y is 1 over root 2a. Okay, like I've been saying throughout the whole time of talking about what we were doing there, we're going to add those two things together, because you can see on the left hand side and the right hand side of the square, obviously they must be equal, but any of the sides of the square would be equal. But 3 add 3, 6 has to be equal to root 2a plus 1 over root 2a. Now, probably the easiest thing to do here is to factorise out the a, and we get a brackets root 2 plus 1 over root 2, close bracket, equals 6. Now we can simplify the thing in the bracket, because that will give us 3 root 2 over 2, and then we're going to divide by that to give us a, which is 2 root 2. That's the side of the square, so we square that, because the area is a squared, which will be 8 centimetres squared. That's a pretty neat solution, and a very interesting kind of dynamical relationship between the two squares there, in the fact that this grey square is 8/9 of the one on the left. Is it always 8/9? I don't know. Or is it just because of the number? If you change the 9 to n, what would the relationship be then? Is it always 8/9? I'd be very surprised if it is. It's probably some relationship to the n, but what that is, that might be an interesting problem to work out and to put down in the comments if you do work that out. Now, the other solution is a really neat one, I think, if you can spot it. So I'm going to go back to this diagram here, and I'm going to add one thing to it. Now, along the diagonal, you might have seen that I labelled those A's in there, and that's because those triangles are isosceles, and so those A's on the top left and the bottom right of the inside triangles there, they have to both be A, because, like I've said, they're isosceles. Now, if we look at the diagonal, the rest of it is the side length of the square, and so you could just put that down as another a, or what you could do is write it as a half a and half a. It doesn't really matter, so you can half a and half a or a, but essentially we're going to end up with a diagonal being 3a, and it's going to be equal to the square root of 6 squared, the height, plus 6 squared, the length, and square root it, because that's Pythagoras. Okay, so you take your height or width of the square, which is 6, square both sides, square root it, that will give us the diagonal. So we can simplify that to root 72, 36 add 36, and that's equal to 3a, which is the diagonal. Now root 72 is 6 root 2, divide by 3 to get a, which is 2 root 2, and then we're back where we were with the last solution. We can just square this now to get the area. The area, like I said before, is 8 centimetres squared. How cool. Right, I think that's a really neat problem. If you enjoyed this video, please drop a like on the video, and if you're not already subscribed to the channel and you've watched this video and you've enjoyed it, or you've watched a few of my videos and you enjoy them, please do consider subscribing to the channel, because I release a new problem solving video every Monday at 5 PM. Thank you for watching, I very much appreciate it, and I hope everybody watching has a great week. Till the next video, I will see you next week, Monday at 5 PM. Bye bye.